Just to give you a heads up on how this is going to work, we're going to do about 5 to 10 minutes of intro on compellent and fluid data, and then we're going to move into some of the Indiana University demos. I'll do a few definitions about clustering in general, just if you haven't seen those things, and then it's for the last 30 to 40 minutes, it's pretty much all demos with Enterprise Manager, Failover Cluster Manager, Hyper-V Manager, and PowerShell in the integrated scripting environment. And I want to ask at the beginning that if you have the opportunity to please fill out an eval at the end, and if you're not, you're like the guy that sells me the car, if you're not extremely satisfied, please at least just put something in the comments as to why you weren't satisfied, because it's extremely helpful. I mean, those comments go straight to me, and it helps me work on future decks. So if there's something you hated in the deck, just please stick it in the comments. If my voice was annoying, put that in the comments. I'll go to voice training. But please, especially if you're not satisfied, please just put something in the comments to let me know what it was that you didn't like. I think of that, it's 8:30. We'll probably go ahead and get rolling here.
All right. Well, good morning, everyone. Thanks for coming. So we're gonna make sure we're on here. All right. We're going to go ahead and get started. So today, what we're going to talk about a little bit, first of all, I'm Justin Braun. I am with Dell Compellent. I manage the Microsoft and Virtualization Solutions team there. I'm just going to spend a few minutes talking about what is fluid data. I have to remember not to stay behind the table because I'm really short, so if I'm here, you guys won't be able to see me. So what we'll do is I just want to talk really quickly about what fluid data is all about. So first of all, how many of you believe that your storage infrastructure is one of the critical pieces of your IT infrastructure? And how many of you are responsible for managing the storage infrastructure? Great. So what fluid data does is it really redefines the data center. What we want to do is we want to focus on having solutions that, because the business expects that the storage is a critical piece of the solution, we need to have the efficiency, we need to have the agility and the resiliency to handle the business and what the business expects from us out of the solution. So given that, the days of dumb storage are pretty much over with. We need to have a solution that's going to offer us what we need and be able to be agile enough to meet our business needs and change with our business needs. So with that being said, I mean, we're going to be able to cut our costs. We're going to be able to optimize our resources and hopefully minimize our IT risk with that solution. One of the key things here is we're always going to put the right data in the right place at the right time at the right price. So I can talk to you about storage all day long, but what I'm going to do is actually take a couple minutes and let our customers tell you what they think of the solution.
I think I didn't kill the Pandora.
1.2 million email messages on a daily basis, 4 quadrillion transactions over a 60-day period.
I'm going to try that one more time.
We have 70 million hits on our web servers per month, 1 million to 1.2 million email messages on a daily basis, 4 quadrillion transactions over a 60-day period on our database servers.
The files don't get smaller, the files get bigger and you get more of them. You're always trying to catch up with the data.
We are always in need of disk space.
We had performance issues, obsolete infrastructure.
Even to do an upgrade required what was called a forklift upgrade.
Essentially replace the whole solution. And we needed flexibility.
We don't want a system that is locked down. We want something that will allow us to migrate from where we're at today to where we're going to go in the future. When we first purchased Compellent, they were fairly new in the industry, but I was confident. Look, you could see it. You looked at that and you went, that makes sense.
With the tiered storage system, we're able to take our data and effectively utilize all of our storage.
You're able to take the data that you don't need in those high tiers and push them down. You can get slower drives that are substantially larger.
We're not wasting that storage space.
This is a significant improvement in efficiency.
Our storage requirements have doubled every year.
You always need more storage than what you have.
Fluid data architecture made growing the SAN really effortless.
We take these drives, we plug them in, and all of a sudden I have a 7 terabyte SAN move to a 25 terabyte SAN.
With no impact to business.
That's huge.
It's an unbelievable feature set.
We realized not only could we have a solid system that was reliable, but one that was easy to administer.
After I saw the interface and I realized anyone can come in here and work on this SAN.
Where we previously had spent about 16 hours a week managing our storage, we now spend 1 hour or less.
Fluid Data has saved the company just a ton of money.
400 to 600,000 pounds in the last year.
Somewhere around $200,000.
40 grand in data storage costs.
So one of the features I really like about Compellent is their snapshot functionality.
If a user messes up a server or if it crashes,
The Compellent system is able to actually recover your data within seconds.
Point, click, go back to where that was, and we're ready to go again.
We know our data is more secure. We know that it is more accessible. We know that it's more reliable.
What Compellent's brought to the industry with the Fluid Data System is a futuristic simplicity.
Superb value, the wealth of features, and the ease of use.
We got a system that was scalable.
It's technology that I'm really behind because I think it is world-changing stuff.
All right.
So I'm Jansen Jones. I'm the Associate Director for Auxiliary Information Technology Infrastructure at Indiana University. I'd like to talk to you briefly today about some of the things that we've been doing with virtualization and with Compellent and Dell over the past couple of years, and then we'll dive into the rest of the stuff. We're going to have, again, primarily a demo-focused session. We'll be looking at the GUIs of Enterprise Manager, Hyper-V Manager, Failover Cluster Manager, Virtual Machine Manager. We're going to be doing some scripting with the ISE and PowerShell. That's the integrated scripting environment. We'll be using the snap-in for Virtual Machine Manager and Compellent, as well as the module for clustering to do some things like spinning up several virtual machines within 30 seconds from having replay on the SAN up to having virtual machines that are Control-Alt-Delete. That whole process is probably about a 10-minute process, and we'll walk through what that looks like in the scripting. And again, as you have questions today, I think we'll have time to answer questions actually in line. If you do have something, you can stop us and ask us along the way. Quickly about Indiana University. We're one of the largest university systems in the U.S. We have 9 campuses serving about 100,000 students. I'm on the Bloomington campus. We have about 40,000 students there. And I manage a team of 6 that provides support for the infrastructure for the most of the business units at the university, including the housing and dining services, parking operations, our hotel and conference center, our card system. So we have a lot of basically line of business apps running IIS, SQL, Oracle. We also manage all of our users. We have 1,100 users, and we manage their file and print. We manage their gold image using Config Manager. And that overall comes out to about 200 servers, and about 99% of those are virtual now on Hyper-V. When we wrote this deck a year ago, there were still some holdouts, and primarily those holdouts were political holdouts. They weren't technical holdouts. We found there was no reason that we couldn't virtualize any of our remaining systems, even, again, our Oracle workloads on 9i10G. Those are running in Hyper-V now as well. We were coming with some pressures for people that would come in that were reselling a technology that would say, we don't get business support if you're on a virtual machine. And usually after you bartered with them for a while, and you could sign a waiver that says, I know I'm on a virtual machine, and if there's a performance problem, I'll have to reproduce this on a physical machine. And once you get through that, then you can move on. The one technical thing that we did have to solve was we still have a few systems that run USB dongle license keys. We found that we can actually virtualize those systems with a USB to network switch. So you basically plug in a USB key into this little box with a network jack on it. It gets an IP address, and you run a little piece of software in your system tray that actually goes out, looks at that IP address, and then sticks that device in Device Manager. So any machine that still needed that, that's a VM as well. So honestly, we have 3 machines left that are physical boxes. They were physical boxes before we started this initiative, and we won't be putting them back on physical boxes. And we actually now charge customers an inconvenience fee of, I think it's $3,000 a year to have a physical box in our rack. So we're all virtual all the way. And that's running on Dell PowerEdge servers. We're running blades, actually, in our system. These are M610 blades. We have 16 of them running all of these particular 200 systems. And those 16 blades are connected up through Fiber Channel to a Compellent storage center. We're using 3 tiers of storage, SSD at the top tier, a Fiber Channel in the medium tier, and SATA at the bottom tier. That comes up to about 50 terabytes is what we're running. However, 15 of that 50 terabytes is just our general purpose file server that everybody has their video collection on, whatever it is that everyone stores there. And we have a lot of, probably 20% of that is your super mission critical data, but it all sits in the same tiers using tier data progression. Whatever needs to come in, we can allow everything that's super important or super mission critical or even just has low latency requirements. We can let it come in at the SSD layer and then tier down into SATA at the block level over time. The file servers, we let them write into Fiber Channel to start with, and then they drop down into SATA. Some test systems, we just set them straight to SATA. We set some log files straight on the SSD. So all of that, just sort of, you get that out of the box with just your storage profile in the UI, and we can actually look at that later. That wasn't originally in the deck, but I realized that would probably be something good to show. Some of our virtualization projects, we actually started virtualizing, I guess, in 2008. Before Windows 2008 shipped, before Hyper-V had released, we started putting virtual workloads on Virtual Server 2005. And from there, everything just got better year after year after year. So we started putting test and dev stuff in Virtual Server, and we pretty much started deploying on Hyper-V as soon as it shipped. We were part of the System Center Virtual Machine Manager TAP in 2008, so we actually had support from Microsoft as we were going forward with beta technology. So we started putting systems in production on the release candidate of Hyper-V, and since then, production Hyper-V, we of course upgraded to R2 through the Windows Server TAP program, and recently participated in the SP1 TAP program. So we're also running a dynamic memory now in our systems. We're running live migration across cluster shared volumes. We're also dipping our toe in the water of multi-site clusters with live volume. I'll be demoing that today for you as well. Before we jump into the demos, I thought it important to actually do some definitions for terms. So, how many out there are familiar with live migration? So the majority of the audience. So live migration, if you don't know, is a migration of a virtual machine from one server to another within a cluster without bringing the machine offline. So on old Hyper-V, before you hit R2, you had their technology was quick migration. Of course, at the time, you could on ESX, you can run vMotion. If you're familiar with the term vMotion, the equivalent would be Microsoft's live migration. You're able to move a machine from one node to another. The process is basically that it copies all of the memory from one machine to another machine, pauses it for about a second, and then flips it over on the other side. So you can move a machine from one server to another within a TCP retry window. So the client doesn't even know that the server moved. So if you look at a multi-site cluster, we'll skip down to there. With that, you have that same process of live migrating, but you can actually have a VM living in city A at 8:01 a.m. and in city B at 8:02 a.m., or even at 8:01 a.m. for that matter, when the migration kicks in, that you, without the user even knowing it, you could actually move the virtual machine to a separate city on separate storage. Again, that's what we'll be demoing today with live volume. Could be a niche scenario, and not a lot of customers may have a dedicated gig pipe between two cities that they're going to run this on. It's a low latency, high bandwidth pipe is sort of what it requires. But if your needs are such that that is what you're looking for, this is a technology that we'll be demoing here that might be interesting to you. So cluster shared volume is a new technology in Windows 2008 R2. And what that technology does is allow you to put multiple virtual machines on a single LUN. Prior to R2, Hyper-V had a limitation of 1 VM per LUN when you clustered. So if you wanted to use drive loaders for those LUNs, you only had 22 VMs that you could put in the cluster. Once you got to your 23rd, you ran out of drive loaders and you needed to move to mount points. But they weren't traditional mount points at the file level. They were volume GUID, so you'd have to know like a 20-character string. You couldn't browse that string in File Explorer. You'd have to go to Start Run, copy and paste the string. It was a little difficult. So there are some ways that you can get around using cluster shared volumes if you don't want to, but they dramatically simplify how you can deploy virtual machines in R2. So we're actually running on CSVs in this system, and we'll be demoing that as well. And the final term here is stretch VLAN. If you're running multi-site clusters across cities, the biggest problem with that customers would generally face is if you don't want to have to be doing a lot of DNS manipulation to have a machine in city A have IP 1234, but in city B have IP 2345, your clients are going to have an outage during that migration time where DNS has to catch back up. So to have a live migration across cities, you need that same VLAN on both sides to where the IP doesn't change. So you live migrate from city A to city B, they're both coming in on the same VLAN. It keeps the same IP in the second city, and the client actually just keeps on running. So we're actually running that in this demo. I'm going to pass it back over to Justin to do some storage-specific explanations, and then we're going to hop into demo.
All right. So how many of you are familiar with snapshots? All right. So Compellent's feature equivalent to a snapshot is called Data Instant Replay or a replay. So that's what we're going to talk about here really quick. Our replays are a little bit different than a traditional snapshot in the sense that when we take a replay of a volume, what we're going to do is freeze the blocks that are on that volume at that time, mark them as read-only. So any new writes that come in are going to be written to new blocks. That means when we want to access a replay or provision or map a replay up to another server, we create what's called a view volume off of that replay. And that's a view essentially into what is contained in the snapshot. So it's going to be a reference back to the original blocks. And these are writable as well. So any new writes that are going to come in will come into that replay volume like a normal volume. In the case of a gold images are useful for doing your server provisioning or even virtual desktop provisioning. In this case, what you're going to do is you can see here that we've got our available storage, which might be the entire SAN. What we're going to do is we're going to create a volume that contains the gold image. And so if we use Windows Server 2008 R2 as an example, your install is going to be anywhere between 7 gig and 12 gig, depending upon what you're doing. So we're going to create that image, and then we can customize it, put all of our standard applications on there, do any other special setup that we need to do, and then sysprep that image. We're going to shut it down. That becomes our gold image. From there, what we can do is take a replay. And then where you're seeing server A, B, and C, that's where we've created view volumes off of that replay, and those are going to be servers that we're going to provision. They're not going to consume any space on the SAN until we power them up. And when we do power them up, it's only going to consume space that are the actual changes coming in. So what you'll find in these cases is these replays, when they're powered up, will consume about 700 megazol. So if you think about the space savings that you can get off of using gold images and replays, it's pretty substantial when you look at an average install size of 11 gigabytes. So provisioning 11 gigabytes times 100 servers versus 700 meg times a bunch of servers, it's pretty substantial savings in that case. So thin provisioning, again, is the idea that we can have a certain amount of space. In this case, you can see here that we've got 3.8 terabytes of physical space. We've got a bunch of 450 gig and 300 gigabyte drives. But what we're doing, what this allows us to do is oversubscribe or over-provision what we actually have on the system. So in the top box, what you're seeing is we've actually presented 10 terabytes of storage across 10 servers for only 3.8 terabytes. And how we're doing that is when we present a volume to the operating system, we're presenting a starting point and an ending point of the volume. But we're not writing any data to that volume until you actually write data as the consumer of the volume. So another example, we present a 100 gigabyte volume to a Windows server. We initialize it or online it, initialize it, format it. It's going to consume about 78 megabytes is all on format. So what you'll see on the SAN side is you've got all these different volumes that are a certain amount of size, but they're consuming very small amounts of data until you actually start writing to them. So live volume is going to enable us to virtualize a volume across two separate arrays. And what this allows us to do is relocate resources on the fly while allowing continuous access and high availability to the users. So the volume never comes offline. And what Jansen, he's going to go into this in more detail and actually show you how this works. But this is going to allow us to do things like planned outages where we maybe have changes in the data center that have to happen. If there's power grid problems, things like that, you can relocate those resources from one site to another. Also, in the case of live migration, this is a good use for that. And again, that's the example that Jansen's going to go through. So Jansen, why don't you walk us through what your environment looks like?
Sure, thanks. So I just had a minor heart attack there. So again, this is basically a demo session running off live data in Indiana, and I just saw my RDP session disconnected in that last 10 seconds. So it's back up now. I'm going to keep my fingers crossed. Pray to the demo gods that the remote desktop connection stays live. So what we're looking at is the actual environment we're going to be working on today. This is up in Indiana. Site 1 is Bloomington. That's the letter B there. Site 2 is I. That's the Indianapolis. And we have 2 storage centers. Your 6412 and 6414 are our 2 demo SANs. That's Storage Center Series 30, I believe, SANs. And these are only running 1 tier of disk. So we're just running on SATA storage today for the demo environment. We have 2 gigs of pipe going between the 2 cities that we're running our 3 VLANs over here. So we have an iSCSI network, our 10.0 network. Our cluster shared volume here is 192.168.1, and we have an internet VLAN where we have guest traffic and management traffic. Our management servers, to be clear, are not internet routable. They're on non-routable addresses, and we're hopping in through a gateway server. So you see S1, S2, and S3. In our case today, we're actually only going to be looking at S2 and S3 because we provisioned S1 before we started the demo. Yes? Yeah, so that's actually what's happening. So the question was, how is our internet routing working? So you see those little dotted lines down at the bottom that show the internet. So primarily at any given time, there's actually, I'm not a NOC guy, so I can't give you all the details. I know when this was originally set up, traffic to both sites were always routing through a single site. But now traffic can actually route between the routers on both sides. There's a cable in the middle that is running, is this a MPLS VPN? I believe is our, I can actually come up with that question for you. But right now what's supposed to happen is that if that breaks in the middle, one of the routers is going to end up having the quorum vote, and it will keep passing traffic. As long as the traffic stays up between the two, traffic is supposed to route on both sides. But if the link between the 2 cities goes down, one side is going to get the vote on the switch side, which is, so it's pre-programmed in that our Bloomington site, in the event that the actual link between the 2 cities goes down, Bloomington takes over. Indy won't route traffic at all. But in the event that it stays up, Bloomington and Indy will route traffic on both sides. And so in that case, occasionally the links between the cities will go down momentarily. So in that case, anything that's in the second site would go down. The cluster would go down. The cluster nodes would go offline. And so we primarily don't leave. So one thing that people talk about, I don't know how this would work from a network perspective, but people say you could load balance your VMs across 2 cities. I don't think that's possible. I think you really need to leave all your VMs in 1 city at a time and only ever move them to a second city if you had to bring the first city down for some reason, like you were going to re-rack your storage or re-rack your cluster nodes. That's one of those rare cases where this technology, if you didn't want to take an outage, you could move all of your VMs over to the nodes in the second city, flip your SAN around to where your second city is the primary LUN, and then actually power down all the servers in the first city, power down the SAN in the second city, or the first city, and do whatever you need to do. When you're done, flip everything back. You can live migrate all your VMs back. So that's what we're going to look at. But in this case, so traffic, the link has to be up for traffic to continue through both cities simultaneously. And so the little 2 lines going out to the internet in this case, assuming that link is up, you actually would have that cloud on both sides. So that originally this is how it was architected, and later it was re-architected to where the internet could travel out both sides. So both of those servers on each side are actually connected through fiber channel in this particular demo. And I don't think I mentioned these servers, in this case, are Dell PowerEdge R810s. They're the new big NUMA boxes. They have 128 gigs of memory and like 32 cores, I think. But in our primary production environment, we're still running the Dell M610 blades. And so all of our workloads, the SQL workloads, the Oracle workloads, the System Center workloads, those are all running on PowerEdge M610s, 16 of those. So we're actually just going to hop into demos here for the rest of the time. So this is a look at Dell Storage Center. This is a look at Compellent Enterprise Manager. How many have seen Enterprise Manager before? Okay, a couple. So I'll do a quick overview of just what Enterprise Manager is. You have a built-in SAN management tool that's Java-based called System Manager. It's primarily if you're only managing a single SAN. And Compellent ships this GUI called Enterprise Manager, which is generally used primarily if you're managing more than one SAN. You could think of it as the equivalent between Hyper-V Manager, which is for a single node, or Virtual Machine Manager, which gives you a view into everything. So this is the software that gives you the view into everything. And in this case, you can see I've got two storage centers, 6412 and 6414. You can see that 6412 has a red dot on it. That's because we actually lost a disk, I think, on Tuesday this week. And so we need to get that swapped out. But because it's a virtual RAID with a hot spare, everything just kept on going. We get an email, you have a disk, you should go probably swap that, etc. But everything should continue to work flawlessly. That's the Indianapolis SAN. This is the Bloomington SAN. And you'll see here that I've got this disk called Demo Gold 12345. These are all replays or view volumes taken from the original Gold Master replay. We'll be looking at those in File Explorer to see what that looks like. So in this case, I have a single server Demo 2 mapped up on this side. And on 6412, I have a single server Demo 3 mapped up on this side. So these are just two nodes in a two-node Hyper-V cluster. And these are old VMs from the last demo. I better delete those to make sure that no demos go horribly wrong. How many of you, again, have used Virtual Machine Manager? Okay, how many have never even seen a Virtual Machine Manager console before? Okay, a couple. So this is the technology that Microsoft ships, System Center Virtual Machine Manager, which is pretty much what I would recommend if you're managing a lot of nodes. Because the problem when you're managing Hyper-V, if you have a lot of nodes, is that you can't get an overall picture into, someone says, my VM 123457 is offline. If you don't have a single pane of glass into where that's at, it's hard to quickly go there and manage it. And secondly, this gives you a lot of general tools around being able to move a VM from one node to another or one cluster to another, script VMs from templates. Templating is actually a really big thing because you can set up all of your hardware profile, guest OS profile to say, I always want this to have 2 procs and 8 gigs of RAM. I want to put in my unattend file, my time zones, etc., and deliver that through this interface. So we'll actually take a look at that as well. Of course, here we have a view into just Server Manager, Failover Cluster Manager. Again, this is another view into the 2-node cluster. I see Demo 2, Demo 3. I see that I've got a few cluster shared volumes online here, Demo Gold 1 through 6. And so without further ado, we're just going to take a look at some of the things that we talked about. One being a replay. From the GUI here, what you can see is I have this Gold Master that I had snapshotted on May 4th at 4:22 p.m. It's 54.47 gigabytes. What's on this line is 5 VHDs. Actually, I'll just show you what's on that line. If I go over here, this is a demo version of it that I just deleted everything off of. This is a demo of the LUN. You'll see that I have 5 folders, and each of them have an R2 VHD running 11 gigabytes. So 11 times 5, 55 gigabytes. Those are my pre-made VHDs that I have sysprepped, ready for quick use. So now I can spin up 10 of those, 15 of those within a couple seconds and then have 100 VHDs sitting in the cluster ready to be provisioned and brought online. And that's what we'll be showing in the demo. So if I wanted to do that from the GUI, if I wanted to bring up a brand new one, I can just say create volume from replay. And in this case, I'll say my new volume from replay, 1, 2, 3. I can check the checkbox right here to create it as a live volume, or I can just leave it on the local storage. One caveat to this right now, which you might not catch, with all the smoke and mirrors you might not catch, but if you're going to run this as a live volume, you actually are going to end up doubling your storage on the SAN, because there's no way that the SAN can replicate the replays across. It's basically going to create a new LUN in order to have it match on both SANs. You can't create the replay on both sides and just magically sync the two up. So if you are going to use multiple SANs with live volume, that's the one caveat, that you're not going to get that same space savings on the SAN. But that's as how you would create a new volume from a replay. So if I ran that and mounted it up to the server, I would, from disk management, just see that new LUN. It's saying that it's 55 gigabytes, but on the SAN, I will have not used any space. So now I've got 55 gigs of new VMs without increasing my SAN space. So that's what Justin was talking about with the replays. The next thing I'm going to show you is the traditional way to create a virtual machine in Virtual Machine Manager, which I'm not a fan of. So we'll show you the way that it's designed, and then the way that we like to do it. I've got a template here called Bits template, and what you'll see here is that I go through the wizard to allow me to name the virtual machine, and I think I'm going to have some problems because my resolution is just a hair too low. See if I can auto-hide this taskbar. There we go. So I can name it my new VM from Bits. I see my hardware profile. I can go in here. This is similar to what you see in Hyper-V Manager. The difference being between Hyper-V Manager and VMM is that this is all pre-saved from templates, and you can have 100 templates based on your user. Yes?
You have dynamic VHDs there. Do you use dynamic VHDs everywhere?
Yes. So
former guidance was if you want to get decent perf, you have to use fixed VHDs, and I'm wondering whether that's changed over time.
yes. So the question is, he says that we're using dynamic VHDs. Do we use that in our production environment? Yes. 100% of our VMs in our production environment are on dynamic VHDs, including the SQL workloads, the Oracle workloads. We, across the board, only use dynamic VHDs. The Hyper-V Best Practice Analyzer still to this day says you're not supposed to use them. I just did a best practices session yesterday. Unfortunately, it was an interactive session, so it wasn't recorded. But the guidance in that and the guidance we posted online from the facts as well are that you see a 90 to 95% performance in a dynamic VHD. So if you're comfortable with that, you gain an enormous amount of storage savings by using the dynamic VHDs, especially when coupled with thin provisioning. So what Justin mentioned is that the compellant natively, by default, and it's difficult to not, only use a thin provisioned LUN. So when we're creating these, they're always a 2 terabyte LUN. These ones that you're looking at, the demo gold, that's a 2 terabyte LUN. So no matter what, that we just always make every LUN 2 terabytes and every VHD dynamic, and then that 2 terabyte LUN ends up using, in this case, 50 gigabytes. And over time, it can grow from 50 gigabytes up to 100 to 200 to 300 to 400. And so long as you have some alerts set to monitor from Ops Manager that you're getting low on disk space on one of your shared volumes, then you can take care of it at that level. And at the SAN level, you can pretty much see you're using 70% of your SAN, you're using 80% of your SAN, go buy another tray. And as soon as you buy that next tray of disks to put in the SAN, you've now taken care of that problem as well, right? So yeah, so we thin provision everything on the SAN, and we use all dynamic VHDs. Question? Yes?
So you don't have a problem with white space from SQL instances generating or setting up all your dynamic space you've allocated for VHDs?
No. So the question was, in SQL, have we had problems with the dynamic VHDs getting a lot of their space utilized and sucked up?
You don't let the white space issue with that, right?
No, I'm sorry.
Yeah, so it's...
They read and write so much that a VHD reports back that this portion that's been read and written from is being used. So the SQL server doesn't see that as available dynamic space. And once the dynamic disk grows to its maximum size that you set up, then you impose your SQL instance.
Okay, so, do you want to go ahead and take that?
I was just going to... I was just going to say, it's the same issue with Exchange as well.
So we're running about 40 SQL servers in our environment, all on dynamic VHDs, and they've all been running for 3 years, and we've never had that issue. So personally, so we set all of our dynamic VHDs to be 127 gigs, and we also break out our database volume and our logs volume onto their own separate 200 gig VHDs, but they're not growing out of proportion. I don't know if it's just the way that our reads and writes are happening, but all of those VHDs are properly sized to what we think they should have inside them.
You just have to be really aware of what your workload is. Obviously, in like an Exchange or SQL environment, you probably don't want to do VHDs if you're mid-size or larger. You want to stick to doing pass-through.
So yeah, so we actually talked a lot about this in the other session as well. But whether you're going to look at an iSCSI volume versus a pass-through disk versus a fixed VHD versus a dynamic VHD, and again, it depends on your workload. So we have, I don't know, a couple thousand people hitting our databases at any given time. We're not running a monster online transaction processing system. So your mileage may vary there, but for our personal use, we have never seen an issue with running SQL workloads or Oracle workloads even in a dynamic VHD. So, okay, in this demo here, what we're basically doing is walking through this template, and we'll go ahead and hit next and see our guest operating system is 64-bit Windows Standard. And I'll say next. It's going to auto deploy by using intelligent placement. That's the virtual machine manager technology to see which server is under the least amount of load based on, you can actually customize over CPU, memory, disk, or network. And in this case, there are no VMs running anywhere in the network, so both nodes are 5 stars. So what happens here is once I hit next and finish, a bits job kicks off. Is everybody familiar with bits? So bits runs the world, right? Bits runs Windows Update, the background intelligent transfer service. So everybody that gets an update in the world every Patch Tuesday is getting that update generally from bits. Bits is a great technology in that on slow networks, dropping networks, that whatever you need to get to the other end generally gets there. It may take a long time, but it'll get there. So depending on what you are wanting to do, you can just use that here. So what that's going to do is take 11 gigabytes out of my virtual machine manager library and copy it over the wire, first from the disk to the machine, then over the network to the host, then back onto the disk, back down to the SAN. So you've got I/O just going everywhere to do this copy, which again, it's easy, it works out of the box, but you're putting a lot of stuff out on the network that you may or may not need to be putting out onto the network. So one of my big requests in Virtual Machine Manager throughout the TAP was give us a way to do this without bits. We can do this at the SAN level through a snapshot. We can even do it from the local machine doing a file copy, and we don't have to take this out on the network. That copy can happen in 5 seconds. Well, at a SAM snapshot, it's instant. If you're just doing a file copy from like your local C drive over to the C:cluster storage CSV, that can take 5 seconds. So you go from a 10-minute copy to a 5 to 10-second copy. And on a single VM, maybe it doesn't matter. You can just go get a cup of coffee while this is running. But if you need to spin up 10 or 15 machines, you don't want to wait an hour and watch all this bits traffic go by, throw unnecessary traffic across your network. So we'll go ahead and let that run, but then I'll also show you then a way that you could do this without. So here we have a C:\cluster storage. If you're not familiar with cluster shared volumes, this will spin up sooner or later. This is just the way some cluster shared volumes work right now in R2, depending on your network environment. It takes it a while to spin up and enumerate everything in that folder, but I'm confident that, yeah, here it shows. I've got my 6 CSVs. I could actually, there's my new VM from Bits that I'm deploying. I'll see that all shows up here momentarily. The actual VHD is going to be in this folder, but it's not showing up yet because they hide the file while it's writing. As soon as the file's done writing, it magically appears, but if I had show hidden files on, I'd see a temp file right there. But let's say I want to spin up a new one and say my faster VM from local copy. In this case, all I'm going to do is actually grab this VHD that's sitting on the root of my C drive. This is something we talked about in the last session. We dramatically dropped down the page file of our C drive because it's not used in Hyper-V. The parent partition doesn't actually need that page file. We've got another deck, so if you want some answers to these questions rather than dive too deep into those, Vert 471, it actually has a lot of those suggestions. You can grab that before the end of the week, and then I think they're actually going to pull that deck down. But so we use our C drive, rather than storing our page file, we actually use it for storing things like gold images, because I can quickly provision from my root of my C drive over to my CSV. I can copy this file much faster than I would copy it from VMM using bits. So once I have that spun up, I can go into Hyper-V Manager or Failover Cluster Manager, either one, and go in and create a new virtual machine. Walk through my wizard. I'm going to say my new local VM. And point it into my cluster shared volume. Actually, if I don't make the file, yeah, I'll get an extra folder, but that's okay. So I'm going to select to use that there, set my memory. So again, this isn't the most optimal way either. So we're progressing through the hierarchy of the most optimal way, which in the end will be scripting. So just to give you the sneak preview there. So interestingly, in this case, am I on the right? I wonder if my CSV moved to the other node. Yes, there's the problem. So that's another in the tips and tricks. I'm not copying directly into my coordinator node. So if I would have created that from demo 3, that's going to be running a lot faster. In this case, I accidentally actually started copying the file over the network again. Rather than go into a deep explanation of what cluster shared volumes are, with cluster shared volumes, every node in the cluster can write to the same disk simultaneously, but only a single node can own that disk and actually do write operations like file grows. And in that case, I'm writing this to the Demo 2 server, but the disk now, it turns out, was living on the Demo 3 server. So that's going to take 5 minutes to copy because I'm copying it over the network, which is what I was going to demo avoiding. Yes, question?
Have separate LUNs that you assign each of the hosts in your cluster to optimize performance, or do you find that the CSV multi-write makes that pretty much irrelevant?
Yeah, so the question was, do we have a LUN for each host in the environment, or using CSVs, does that become irrelevant? Again, what we've found is that usually having about 1 LUN per server as a CSV, so if you have a 5-node cluster, having 5 CSVs in there and sort of stacking the VMs along the lines of the CSV comes out fairly well, and then you can live migrate for patching and everything else, but you're still keeping them sort of lined up. So it doesn't matter if you actually let them all go, so you can have 10 VMs on node 1, but the CSV is actually living on node 2. We found that works unless you get a network blip or a network outage or somebody reboots a domain controller and your SMB traffic goes south. But if normally it will work just the same and you won't see any difference. It only really matters if you're doing a file level operation. So if you are doing a compact of a VHD or expanding a VHD or merging a snapshot or doing a file copy like I just did, you need to always make sure and do that on the coordinator node. But if you are just doing general, the VM's up and running, it doesn't matter. It can live anywhere.
What about having one giant, like 10-terabyte LUN for all of the nodes within a cluster?
So the question is, what about just having one big LUN for every single node in the cluster to use? And that will actually work. The thing that you might run into is once you have all your eggs in one basket, if you want to back up that volume and it goes into redirected I/O mode for an extended period of time, you can cause some issues there with the performance slowing down when you're doing your backups. And there's a much longer conversation to be had on that. Unfortunately, that was all in the V471 talk. We can actually talk some more afterwards about that, but the recommendation is it's probably not best to do that just because you run into some situations where it takes a really long time to recover that LUN if you ever need to recover that LUN. Just getting into 10 terabyte lens in general, you sort of get into a messy situation if you ever end up in a check disk state or a number of things. So if you don't have to do it, you're better off keeping things around the 1 or 2 terabyte size. They're more manageable. They're more manageable for backups. They're more manageable in the event of a recovery. They're more manageable in the event that you get into a redirected I/O state for whatever reason, like an HBA losing its connection, breaking the fiber, any number of things. You can sort of just spread out your stress of the event. I'm going to go ahead and do a rapid provisioning demo now. I'm going to cancel out of that one. So we're going to hop into PowerShell. Yeah, my multiple hidden track bars here are turning to be a bit problematic. So, I don't have a scroll bar there. So if I bring this one back, if I can trick this resolution into coming onto my side. There we go. And now it magically appears. Okay, so I've got this script here called rapidprovision.ps1. And it's a pretty simple script. What I'm doing with this, I have a function that I've created. It's just a wrapper. How many are out there using PowerShell? Okay, so you're familiar with basic commandlets for the most part. If you're not, PowerShell is awesome. There's tons of PowerShell talks recorded here. Go watch some PowerShell talks. There's a new book that just came out yesterday by Bruce Payette. It's his version 2 of PowerShell in action. I'm a huge fan of PowerShell in general. I would recommend. That's the first book I read. It's an awesome book. So just you get that one for free. Go find Bruce Payette's PowerShell in Action V2. So you don't get the book for free. You just get the tip for free. This script is basically going to take 5 parameters from a CSV file. Don't confuse it with the cluster shared volume. This is the traditional comma-separated value file that you're familiar with from the 80s. I'm going to just pass 5 comma-delimited values into a function that's going to turn around and spin up 5 VMs really quick. So at the end of this script, I'm going to have 5 VMs up and running in about a minute off of a sysprepped image. So let's just walk the script. The first thing we're going to do is connect to our VMM server. We're going to make a new job string just to identify all these tasks are going to run in one job. We're going to get our template from Virtual Machine Manager that's just called the 2K8R2SP1 Gold template. We'll specify which host we want to put our VMs on. We're going to use the move-virtual hard disk command. So that's the rapid provisioning. That's what doesn't exist in the graphical interface. By running that single command, you tell VMM, whatever is in this template, which is actually in this case just a blank hard drive, don't use that, but instead use this destination path that's already out on your server. So just use the whole VMM stack, but don't do any kind of bits copy of a VM. Just use whatever's already out there. So I'm going to say move virtual hard disk of IDE bus 0 lun 0, which is just your default primary IDE device. Use this cluster storage path, and then I'm going to hit the variable out of my script. I'm going to attach a network adapter and spin it right up. So if we look below here, we'll see I've got just 2 lines that say import this CSV. We can actually take a look at the CSV. This is the file I'm picking up. I'm going to import this. I've got 5 VMs here, so I'm going to have Bob, Jansen, Steve, Bill G, and Brad. These 5 VMs that's going to be the names of the VMs. The Demo Gold 1 is the actual cluster shared volume LUN that I've already mounted up. I'm going to show you the script that mounts that up as well. The folder names, as you saw before, we just have 1, 2, 3, 4, 5 for our folder names. Next is number of processors they have. And finally, we have the amount of memory in the box in megabytes. So I'm going to get the CSV and say for each line in that file, create a new VM passing those parameters. And paste that in. Just want to double check that the CSV was actually pointing to the right LUN because I was changing. Okay, so we're going to go to Demo Gold 1 across all 5 of these, which Demo Gold 1 we checked that's ready to go. So the script's done. So that was it. So you didn't see much there. So let's hop over to the back to the Virtual Machine Manager view and see that I've got these 5 VMs spinning up now: Bill G, Bob, Brad, Jansen, and Steve. I can look in the jobs view and see what they're doing. They are not doing the file copies. So the file copies already happened, right? It didn't happen at all because I used the replay off the SAN. I just took that SAN LUN, the gold image, and said use that instead. Don't do any file copies, so that no I/O ever took place to bring these 5 machines up. There was just simply a map process, and we're done. So what's happening right now is that they're actually running the first sysprep. So they're coming on. These were all 5 sysprepped images. They're going to do their device detection, run everything that was in the unattend file, set the time zone, set the product key, etc. So in about 2 minutes, we'll have those VMs up and ready at a Control-Alt-Delete screen. So take a moment and pause a question.
If I understand it correctly, you have a gold LUN that has a whole bunch of your gold images in different folders.
Yes.
So when you snap that LUN copy, you now can do 5 machines because you already have 5 copies of that gold VHD on there.
Correct. So the question was specifically, are we stacking all of the VHDs on a LUN? And the answer to that is yes. And the reason for that is if you just have a single VHD on your gold snapped LUN, you're going to end up with hundreds and hundreds of LUNs, right? So we thought it's much more optimal then if you put 5, 10, 15 VHDs on the LUN ahead of time. You use all that space up that very first time, but then you can spin the LUN of 15 VHDs up a second and a third time, and now you've got 45 machines. The 5th time, now you've got 60 machines. And so that allows you to exponentially run those. Now, there are some caveats to that. If you're familiar with snapshots and differencing disks, you don't hit all of that at the same level, at the SAN level, and you sort of have to look at what your specific use case was. It might be good for a training room or a VDI, but what's going to happen is over time, the deltas on that VHD or that LUN are going to grow bigger than what your original snapshot LUN was. So in 5 years, that initial read-only part that was only 55 gigs may have a terabyte of deltas on it, in which case you might say, is that still the most valuable way to have done it? But especially if you're going to spin up stuff quickly, tear it back down, do training rooms, I'm going to spin up 50 machines next week for this conference or for my demos that I'm going to go do. As soon as that's over, I can just spin them right back down. I didn't use any space on the SAN for the entire time of my demo. I could bring up 100 machines, use a few megs, and turn them back off. So it doesn't, again, apply to every case, but it is a case that is useful in situations that you find yourself needing to spin up a whole bunch of VMs quickly, especially if they're not going to be used for a really long time. So yeah, in this particular case, we had 5 VMs on the LUN. I originally had 10 VMs on the LUN, but again, as I mentioned, because you don't get that saved space from doing live volume because it has to replicate over the wire, that 50 gigs replicating over the wire was a little bit faster than having 100 gigs replicate over the wire every time I ran the demo. But originally, I had this set up with 10 VHDs on the CSV. And if you're not doing replication between 2 SANs, yeah, the sky's the limit. Put 20 on there, just whatever sizing your virtual server. So we're going to take a look at the big monster script here that has all the magic in it for doing compellent work. So compellent, I think, what's it been now, 2 years, 3 years ago? When the
Almost
first
3 years.
So compellent 3 years ago actually made this awesome snap-in, PowerShell snap-in for their SAN called the Compellent Storage Center Snap-in.
Command set.
Command set. It's sort of, yeah.
Compellent Storage Center command set for Windows PowerShell.
Okay, so it changes a little bit over time in the start menu. So there was a V5 name and a V6 name. So yeah, the Storage Center command set. So, but before that, Compellent released the Java tool, compcu.jar. It's cross-platform, and you can run against that. Well, it's just like running DiskPart in Windows. Once you've started using object-oriented scripts, it's very difficult to go back and try and do regular expression parsing, etc., to get LUN numbers out of a big string of text. So, in my opinion, this made things quite dramatically different and easy to manage. So Compellent also gives you a bonus in that you can actually do Windows disk management from this snap-in. So as far as I know, there is still no freely available Windows disk management snap-in out there. So if you want to do disk management at the command line built into Windows, your option is DiskPart, right? So you DiskPart, list disk, rescan disk, online disk, offline disk, clear read-only flag, all that fun stuff. So again, you're having to take a notepad file and inject that into DiskPart because Windows doesn't give you any good way to run DiskPart commands programmatically. So in this case, you have all those commands built into this snap-in, and we can actually take a look at some of those as well. So this is a pretty long script, and we're not going to walk the entire script, but we'll walk through some highlights. The first thing that we're doing is we're adding snap-ins and modules. For those of you that aren't familiar with PowerShell snap-ins and modules, in PowerShell version 1, if some third party wanted to have a whole bunch of commandlets that they could just dump into PowerShell, they delivered that through the mechanism of a snap-in. And so as soon as you run this command add snap-in, all the base commandlets that are in PowerShell, now you have all these additional commandlets provided by whatever the third party is. In this case, we get all the storage center commandlets by adding the Compellent Storage Center PS snap-in. Next, we're running the Virtual Machine Manager snap-in. That allows us to do creation of our virtual machines. That was actually the demo that we just showed, was using the Virtual Machine Manager snap-in. And then finally, we have a module. Modules are V2 PowerShell snap-ins, basically. They grew on what snap-ins were in V1. They have more, error checking, more flexibility, and some things you can do with them. So everything that was a snap-in will, in time, move to modules. And so we're adding the failover cluster module to get the failover cluster commandlets built in. These lines that I've got commented out, the green lines, those are, if I didn't already have default connections saved into my storage center from this. So I have these currently saved on my box for demo purposes, so I don't have to type in my password. I can, that's encrypted through my local set of credentials onto the box. So the first thing we're going to do, I've got a zillion of these lines that say write debug, and that's just sort of one of my personal things when I'm writing a PowerShell script. This top line up here, I had debug preference equals continue. If you set that in PowerShell, it will write all debug commands out into your window. If you change this to silently continue, you don't see any of it. So if I'm writing a long script, I would just write everything to the debug window, and at the end, once it's done, I can switch it to silent, and then I don't get all that extra output. If I ever want to go back and troubleshoot, then I can go back to here. So for the purposes of the demo, I'll leave it as continue. So I'm writing all of these things to walk through the stack. This is also something I can use in place of just writing lots of comments. Usually in my scripts, instead of writing comments in the script, I just write a debug line, and then it's a twofer, right? I get it at runtime, and I get it just by reading it as I walk the stack. So I'm going to do a couple checks here at the beginning of the script to say, make sure that the LUN I'm trying to create doesn't already exist on the server. If I'm trying to create a LUN that already exists, I hit all kinds of collisions between SAN naming, server naming, so obviously I don't want to have the LUN called demo gold 5 7 times. So I put this, or even 2 times for that matter. So I put this at the beginning to do some things to already check and make sure that there's nothing that's going to crash the script early on. I also do some things here that we probably don't want to do a deep dive of, but I'm making sure that the available storage group is on the node of the cluster that I'm creating this. That just makes, without going into a lot of detail, that makes everything work better. And if you want to know more about that, you can ask me about that after the session. So if we get through our debug code, the first thing that happens here, so this is the gotcha with using replays and clusters. Replays and clusters don't work well right out of the box. They take a couple tweaks because what happens is when you create a replay at the SAN level, it is the same disk. It has the same disk signature. It has the same volume serial number. If you attach that to a live cluster, it thinks you just reattach the same disk again, and it'll actually put a reservation on that disk. Well, it doesn't think it's the exact same disk. What happens is that it puts a reservation on the disk and you can't use it. So as soon as you mount up a new cluster disk from a replay, the cluster DLL instantly just says, this is a reserved disk, no node can use it, and it's just locked. So what you have to actually do is pre-plan that anytime you bring up a replay, you're going to change the disk serial number, or the disk signature and the volume serial number. By doing that, it's unique. So you bring up this disk, change the disk signature, change the volume serial number. Now it doesn't collide at any level in the stack within what Windows sees and what Virtual Machine Manager sees, and everything plays along nicely. Well, it just so happens that those are hex values. So a guy at Compellent by the name of Shane Burton, back in the early days of doing some of these scripting sets, generated this function that will generate a bunch of hex numbers, use one for the signature, one for the volume serial number. So I'm using that care of Shane, and I'll thank him for that. So the next bit of code actually goes out here. This is short for a get-wmi object. This is actually going out to the server, in this case BLAIT demo 2, and saying, get me all of the signatures for every disk in the cluster right now. And then generate some unique hex number, and then make sure that it doesn't match anything. So if I run that list, don't see any matches, that's the hex number I'm going to use. If for some odd reason I hit in Fate that I matched this random hex code, go generate it again 9 more times until you get a unique. At that point, we're going to preset a lot of variables. In PowerShell command set version 6 from Compellent, they made everything pipelinable for the most part, rather than filtering. If you know what that means, everything is declared at the set level from a pipe rather than a filter. If you don't know, don't worry about that. So what we're doing right now is predefining all of the things that we're going to be using as objects in our script. My quality of service is just $QoS. The quality of service on the destination side, QoSD. Presetting my demo server on each side. So here's where the magic starts to happen. I set my gold replay object here using get-sc replay. So that's the same thing as when I did a right-click and create new view volume from this. Well, actually, right now I'm just getting it. I'll be setting it. But 718-1, 718 was my demo gold replay. The -1 is the snapshot that was taken on May 4th or May 14th, whatever that date was. So then I'm going to write some more debug windows. And then here's where I'm creating the volume. So that line right here, when I did the right-click, create new view volume, this is that same thing at the PowerShell line. I say create a new volume. The name is going to be whatever the parameter was that was passed in from the script, and then everything in the rest of the row are just those variables I set ahead. So the parent folder that it's going to sit in is just basically the same as where is it, the Windows equivalent would be where is it in Seagull and Windows Explorer, what's the path. And then the source replay, that's the one we just got right here. And once I run that, I'll write a new debug saying I'm going to go out there and make sure that it created it. I'm just going to double check, make sure that it created it. So again, I get the volume again. I see, yes, it's there, and I move on. And then I flip it over to a live volume. So the command to create a live volume from an existing volume, and again, what that does is it kicks off an asynchronous replication to your second SAN, and then makes a virtual serial number. So both SANs actually have the same serial number that they're going to present to Windows. Even though they have a unique serial number below, they have a matching serial number they're going to present to Windows, and that's happening in the new live volume creation process. As part of that, you have to specify what QoS settings you want to use. So we're passing that there with the replication settings, and then we're setting our volume parent folder, and we're going to replicate the active replay. So once we've created the new live volume, we simply map it up to both nodes of the cluster. Again, normally you would, from your SAN UI, just do a right-click, make a new volume map, point at the LUN, point at the server. So we're doing that from the script the same way. We just say a new volume map. This was the LUN again from the higher up in the script and the server. We do the same thing on the remote side with demo 3. And then at that point, we actually start doing the Windows commandlets. So this rescan disk device is actually doing that equivalent of going, remoting to that machine, opening up Server Manager, clicking on Disk Management, right-clicking, and saying rescan disks. So even if I'm not doing any SAN work at all, I always have this loaded because if I ever need to do anything with disk management on a server, it's so much faster and so much easier to do this at a command line, which is always automatically on remotely if you have your server set up to allow remote management, that I just always do this instead of going into the GUI, even if I'm not doing SAN work. So I'm going to do a rescan disk on both of those servers, make sure that I see it on both sides. And here's where we're actually changing the serial number. The same thing, we're making it unique so that Virtual Machine Manager doesn't get confused. Virtual Machine Manager, this was actually a bug we found later. To begin with, we only ever used to change the disk signature, and then we found that Virtual Machine Manager started throwing that we were in an unsupported cluster configuration on a regular basis. And the reason why is it's actually running some code to get serial numbers. And if it sees the same serial number twice in the cluster, then it says something's wrong. We never knew about that, and everything continues to work, but Virtual Machine Manager doesn't like it. So we started changing the serial number to put VMM's mind at ease. So we changed the serial number, and then the next thing we're going to do is actually do some work with changing the volume serial number. And so with that, we're doing a new thing called a PS session. And this is sort of getting into advanced PowerShell. This is new in V2. There was a PowerShell 400, I think it was a PowerShell 471 yesterday maybe. That was Jeffrey Snover and Dan Harmon. They do some demos on this. This is an amazing, amazing commandlet. What's happening is if you're using WinRM or WSMan, you can basically SSH into any server and run anything, or in this case, you can actually pass scripts to an open listening session. So I'm firing off a new PowerShell session using WinRM or WSMan over to BLEIT Demo 2, and I'm going to run a series of commands on that server from this script, and then at the end clean up the session. So in this case, I'm invoking a command that says c:\volumeid.exe. Sometimes people have in the past used psexec. If I need to do some remote command on a server like dir or whatever it is that I need to do, I can just do psexec space whatever. So this is the PowerShell version of that. So I'm firing off a PowerShell session on that machine, and I'm actually going to run this. This is actually a sysinternals tool from Mark Russinovich. This is what's actually changing the volume ID on the disk to make it unique. So I'm calling that from PowerShell, changing the disk signature, and at that point I'm going to add that disk into clustered storage using the cluster commandlets. I just say get cluster available disk and add that in. At the same time, I'm going to add it as a CSV, and then it shows up in File Explorer. So that's sort of the gist of it. I've got about 180 lines here. Only about 30 of those are actually doing things. The rest are comments and debug checkers. So for the most part, if you just wanted to write this up for a quick one-off, you've got 20 or 30 lines, and you're going to get the end-to-end scenario. So let's see if we can give this a whirl. Had some red text up there. I need to make sure. Maybe I had some non-commented code at the bottom. Yeah. I think I still had the old script in. Yeah, I had the old script in my command line, so the copy-paste didn't work there. But I think I've actually still got this loaded. I'm just going to try and run it, and we'll see what happens. No. So let's try and repaste that. Okay, I'm going to have to read the red text.
Those VMs already exist on that location.
This is telling me that the create new JJ, or was this the old one? Yeah. My function, unless I didn't get the control A. Yeah, I'm fighting this resolution here. Unfortunately, this is the optimal resolution for presenting, but it's not the optimal resolution for looking at a script. So for whatever reason, it's not letting me scroll. Let's see if I... Hey, if I don't maximize, I can scroll. Let's try this one more time. Might actually be better to go to my last known good version of that script off of the desktop and try that. There we go. So apparently some keystrokes had happened somewhere up there because I had the star in the script tells me that the script had been modified. And so now let's try this one more time. Okay, so all of that debug command that I was showing you in the script, that's all going to show up on the screen as this occurs. So at this moment, it's checking the parameters. It's actually also going out to the server to make sure this disk doesn't exist. The debug window should have been one line above, but at this moment, it's actually connecting to the servers. It says that everything passes initial checks. Things are where they're supposed to be. It's now creating a new line using the following values. It's creating the replay. It's converting that to a live volume. This is the longest pause in the script because what it's actually doing now is setting up asynchronous replication across two SANs. It's calling into the second SAN. It's saying, I have this new disk. I want you to create it on your side. This is the replication QoS we're going to use. And also go ahead and make this available to other servers on the second side, on the second SAN. Present this up. Normally, if you're doing replication and you're not doing live replication, that's going to be a warm disk rather than a hot disk. It's not going to be available unless something failed over. In this case, what live volume gives you is the LUN is live on both sides simultaneously. That's the magic that allows you to have a multi-site cluster because the storage looks like the same storage even though you're in the separate city. So once that volume converts over to live, it will fire off the rest of the way through. In the meantime, I'm going to make sure that the VMs I had in the oven earlier are still there. Okay, I do see those. I'm going to turn one of them on. And then come back. But I have to maximize again to get my taskbar back. There we go. So, okay, here we see it's flying by at this point. The rest of it runs pretty fast. It's got the live volume up. It sees it on both sides. It's mapped it to server 1. It's mapped it to server 2. It's rescanning disks. It's changing the serial number. It changed the serial number, it changed the disk signature, it changes the volume label. I'm offlining and onlining the disk because when you change the signature, it doesn't take place until you offline and online it. Now I'm renaming the LUN inside Windows. And that's really just the best practice, so whatever you see in Windows is also the same name as what you see on the SAN. It's added the clustered storage. It's adding it to the CSV. It's renaming it inside the CSV so it matches, again, the name of the SAN, and it's done. And it tore down the session. So if I go over here and look in my cluster shared volume list now, there's Demo Gold 9, which I apparently didn't use caps for on that one, so we know that's the one we just did. And if I browse over into C::cluster cluster storage, let it spin there for a minute, now we'll see Demo Gold 9 with 5 new VHDs. So if I needed to make that 10 VHDs, I needed to make that 100 VHDs, I can literally, that was the amount of time that would have taken. That 2 minutes, and that's just because we're using live volume. If we didn't have live volume in that mix, that would have been 20 seconds. So you could have 100 VMs up and running in a minute or two. And there's my Demo Gold 9. So we just created, those are those same 5 folders. I could then simply go into my, that same PowerShell script, pass Demo Gold 9 instead of Demo Gold 1, create my 5 VMs with my 5 new names, etc. And that's sort of the process. So given that, that's sort of the root of the demo, but I know there's a lot of meat there. It's a bit chewy, as Jeffrey Snover would say. So if you have questions about how that works, now's a good time to ask those. Or if any questions about live volume or the scripting or anything in the midst of that. Yes?
So number one, will you make all of the scripts available so we can learn from them?
Yes, so there's always a catch when you're doing this kind of scripting. There's a risk that some variable could wreak total havoc in your environment, since this isn't just like drawing something on the screen, but actually managing your enterprise storage. I will make it available directly to anybody that directly asks me, and once it's cleaned up more, I'll actually post it online, but I'm uncomfortable about posting it in its current state, because even though I've got an extra 100 lines of debugging in there, before I would feel comfortable giving it to somebody else, I'd probably need about 300 lines of debugging in there. Because especially with a script like this, once you've written it, you know when you get the red text on the screen where to go look. But if someone hands this to you, you might end up in a bad state with LUNs sitting in odd places that you didn't quite expect. So yes, I can get you this with a caveat that you need to use at your own risk after having studied the script for some time.
And are there other infrastructure elements within your environment that are key to making this work? So the two that I think about are, we have fixed IP networks. So like, how do I assign an IP when I spin up that machine in PowerShell? Or I have naming conventions, so I have to name my machines, first 3 characters is the region, next 2 characters is the data center, next, stuff like that.
Yeah, that reminds me. Thank you very much for that question, because that reminds me I still have a piece of demo left here. So the only things that are required for this whole thing, we don't use DHCP at all. We use static IPs. So in the guest, we generally set the IP afterward, and I actually have a demo of how we're doing that under this script. In this case, I've got 2 lines here at the bottom. I just powered up the Janssen VM, so let me change this to say Janssen. And I also didn't demo the live migration yet, so that's the last piece to show. So what I've got here is a $VFD equals get virtual floppy disk. This is a particular GUID that I already know. I'm getting a virtual floppy disk that has nothing but a NetSH script on it. So my NetSH script allows me to set all of my particular machines' custom IP subnet gateway DNS wins. And because you sort of got the chicken and the egg with a VM if you're not using DHCP, right? You can't manage a machine remotely at all until you can get its IP set. And there's no way to get this file there easily unless you've already got it baked in, unless you want to do this. So this is the quick way for me to get any file onto a machine that's not network attached. I just have these VFDs laying around, and I can just throw so I have a single 3-line text file on this VFD. I'm going to run this. Hope that I get back nothing, I believe. Okay, so now if I go into Virtual Machine Manager and look at the Janssen VM, I should see that it has a floppy drive called NICconfig, and it does. That was what I just attached. And so as far as naming convention goes, that 3 characters or whatever, in this case, in this demo, that would have just come in at the CSV level. So if you're going to pull this in from Excel or even just from your function, you can call it whatever you want, and that part all just works. So the main piece that's missing, when we look at the way the general virtual machine manager custom, we're again part of the VMM TAP, the thing that we generally do differently than what they say a lot of customers do differently is that we don't use DHCP anywhere in our server room, period. We just don't use DHCP. So when they expect to see something like Pixie Boot, for example, in VMM 2012, or just DHCP for creating new VMs for services, we don't do those things. So we always have to come back in at the static level. Now in VMM 2012, they actually allow you to, and the beta is available, you can go get that. They actually allow you to set static IP pools within VMM. So when you're assigning or creating a new VM using what we just did, you have a radio button so you can say use DHCP or use an IP out of my static pool. And they'll actually do the IP pool management for you. So as long as you know that the ones that are in VMM are truly available, you can do that. So I've got this weird resolution VM here that's now up, and I should have a floppy drive in there. And I'm going to look at this NetSH script. And so let's just copy this first line in, make sure that applies. I was getting some weird issues with that earlier, and it worked better when I put in this first line by itself. Oh, yeah, So I'm in like triple nested RDP session, so I'm a little scared to, in general, whenever, I'm sure everyone's familiar with the triple nested RDP, especially if you have to deal with any compliance or gateway servers that, in general, at the end of the day, you have to minimize, minimize, minimize. Invariably, the Windows key is somewhere you don't expect it to be. But yeah, that very well would probably fix it, but I'm afraid to try it live. So now I'm going to do an IP config, and I see that I've got this new IP, 1079.17.95, and I'm going to try pinging a server to make sure that I'm live, hitting the IUEDU. So now I'm going to hop back into the host machine. And kick off a ping window to that. 1079, 1795? Yeah. I'm going to give you on your toes. 195? Okay, so I got my ping. Fire that off. So the last thing I wanted to demo here was actually live migration and live volume. So in this case, we're in the primary data center, right? We're in Bloomington on both sides. I'm going to go into VMM and put this machine into maintenance mode. So what maintenance mode does is it actually drains all the VMs off a server using live migration and puts them on whatever other nodes are available in your cluster. So what's going to happen here is the VM that I'm open and running and actively pinging here is going to, you see it's now under migration. It's moving, it's literally at this moment moving from Bloomington, Indiana, 50 miles up the highway to Indianapolis, Indiana. So it's going from Storage Center 6414 to Storage Center 6412. So we should generally see one ping drop. Sometimes we see one ping drop, sometimes we don't. As soon as this switches off of the under migration to online, we'll know that it's on the other side. I could be RDP'd into this session right now. If this is a file server, I can have open file sessions. If it's a web server, open web sessions, SQL server, open SQL sessions. As long as that flip happens within the TCP retry window, there's my missed ping. Okay, that was when it paused that one moment to go offline online. And now we're running in Indianapolis. So the final step to that is if I wanted to actually do maintenance on that SAN in Bloomington, if it will let me have my taskbar back one last time, I can go into Enterprise Manager. I can do this either from the command line or I can do it from inside here, but I can actually do that volume swap. So in this case, I'll actually go in here and do the volume swap. And that's going to flip now that LUN from Bloomington to Indianapolis. So my VM's already living in Indy, but the storage, the primary volume is still in Bloomington. So as soon as that swap finishes, it's going to do one last snapshot, flip the LUN. I could actually power down the Bloomington SAN. That's sort of the end-to-end process of spinning up a large number of VMs and then moving them to the second data center. Granted, if you're going to do that in real life, it would take slightly longer than an hour, but that's sort of the general process of what it looks like. So with that, we have just a couple minutes left for Q&A, and we'll open that up right now. So with that, I think that's it. So remember, we are actually collecting cards for today's session on the way out, and so make sure that if you've got your card on your chair that you have that filled out and turned in. Thank you very much for attending, and enjoy the rest of your Tech Ed. Also, please remember to submit an evaluation if you have the opportunity, and if you're not extremely satisfied, please leave comments for me. Thank you very much.